Okay, so let's get started on our chapter 3. We're going to be talking about describing data, and really when we're describing data, we're talking about 5 things. The first thing we'll be covering is the center of the data. Where is the middle? What's most of the data doing? That's really what we're talking about, center. We'll talk about variation, how is the data changing, the distribution, any outliers. If you've never heard of outliers, we'll talk about outliers for a while, and then if there's any changes over time, how the data is changing. So let's get started. If you're keeping track, we're on chapter 3. And we're describing data. And the 5 characteristics, again, that we're going to be talking about are the center, any variation we might have, how the data is distributed, whether it's normally distributed or something else. If there are any outliers, we'll talk about those in a bit. And lastly, any changes over time. Okay, our first characteristic is center. And what we mean by center is really the middle of our data set. What's happening kind of the most often is usually what we think of when we say is center. What value is most of the data surrounding? That's our center. So when we say that, we can think of it kind of like the middle of our data set. And really, we have 3 ways of describing the center. At least 3 common ways. I'll put that over here. The first way that we describe the center is if I would say to you this. If I said, oh, it's just the average. You ever heard the average before? Do you know how to find an average? If you say in your head, yeah, you're probably talking about the first average that I'm talking about. You see, there's 3 averages we'll talk about, 3 centers, 3 ways to find the center. And the first one is like the most common one. It's the one that you think of when I say the average. If you're going to find the average age of this classroom, what would you do? I'm sorry, the average age of the classroom, that doesn't make sense. I mean the average age of the people in the classroom. The classroom's like 5 years old. You guys are more than 5. So the average age of the people in this classroom, how would you do that? Say that louder so I can hear it.
Add all the ages up and then divide by the number of people.
Exactly. Is that what you guys are thinking also? That type of average, that center, that's called the mean average. So when we say center, we could be talking about the mean, and we're going to be using the mean quite a bit in this class. What we mean by the mean is the arithmetic average. And basically, you add up all the things, you divide by the number of things you added. And that's really what our average does. Like in our class, if we wanted to find the average age, she's absolutely right. We'd add everyone's age together, and we divide by how many people were in here right now. And we, whatever we get, that would be the average, what most people would be close to. So we add all the values and divide by the number of values you added. We're going to make this a lot easier in that definition, though. We're going to use some symbols to represent this. So when we were talking about the mean, let's try to make it a little bit more mathy and introduce some symbols here. The mean is going to equal, we know what that means. Well, it is a division problem, right? So a division problem implies we're going to have a fraction here. Your favorite. You love fractions, don't you? Don't you? No one likes fractions, they're harder. But this just means division in our case. The mean is we're adding up all the values, so how can we represent adding up all this stuff? We used a symbol earlier in this class that did that. What was that? Sigma. Yeah, that's sigma. That's exactly right. That's sigma. So we're adding up all the values. And you know what we're going to use for the letter of our values is the same thing you use for a letter for any other math class that you don't know the exact value of. What's that? X. Yeah, some sort of variable. In our case, we use x. You're exactly right. So sum of x, that means you're adding up all the data values that you have, and we're going to divide it by the number of values. Now I'll give you a better way to represent this in a second. Number of values. Now I do have to give you some notation over here because this one, I can't give you one letter yet because it's going to depend on something. Now I'm going to tell you what it depends on in like 20 seconds, 2 minutes and 20 seconds, okay? About then. So we have, the mean is you add everything up, you divide by the number of values you added. Are you okay with the notation here so far? So our sigma means sum. X is the variable we use for our data, or a data value. Now for this thing, we're going to use two different letters to represent the number of values. Listen carefully. We're going to use two different letters to represent the number of values. It depends on whether you're talking about the average of a population or the average of a sample. Do you remember the differences there? Parameters dealt with populations and statistics dealt with samples. Remember that? Well, there's differences in some of the formulas we use. Not in this particular one, but in some of the formulas they're different if you're talking about a population versus if you're talking about a sample. And so we have different letters to show that. That's the only reason why. You're going to do the same math, it's just how it's what you're calling it. Nod your head if you're with me on that. Okay, so we're going to use two different letters here. The lowercase letter n stands for the number of values if you're talking about a sample. So number of items or values, number of items or values in a sample. Can you guess what we're going to use for a population? It's not little n, big N. Populations are generally bigger, right? So we use big N. Would you like a hand motion too? Promise we can have fun in here. It's legal. So little n stands for the number of items in a sample. Big N stands for the number of items in a population. If for chance you know all those pieces of information. Number of items in a population. Well, then that also means if we have a symbol for the mean, it's going to be different for a sample and for a population. Well, that makes sense because the n's are going to be different for a sample and a population. So we can call mean by two different things depending on whether we're talking about a sample or a population. Again, if we're talking about the mean of a sample, what we do as we write this x, just like you would a variable, but you're going to put something on top of it. This little bar. So it's x with a little bar on top. You know how you say that? X bar. Seriously, not even making that up. Honestly. So this is x bar. It's the mean. It's the sample mean. If we talk about a population mean, we're not going to use x bar. We're going to use this Greek letter. Looks like that. Do you see how it kind of looks like an M and it kind of looks like a U? Do you see that? Do you know how you say that? Mu. It's kind of fun. Mu, like a really weird cow. Mu. You know, I used to live on a dairy. I did, and I developed the best cow noise ever. Maybe I'll share it with you sometime. But after listening to like millions of cows, well, actually, it was like 6,000 cows. But I heard. Let's see if I can do it. It's just like that. Wasn't that pretty good? Yeah. I had lots of practice, folks. Population mean. How my dairy friends would be proud of me. Okay, so we have this idea of mean. It's the first center of our data. It's the arithmetic average means. Basically, in either case, you're going to be adding up all your entries and divided by the number of values you just added. We just call it different things depending on different cases, whether we're talking about samples or populations. So for a sample, we have this x bar, and we go, the sample is going to be the sum of x. Sample means sum of x divided by the number of values. In our case, if we're talking about sample mean, notice how this sample mean is x bar. What n should we use, a big N or a little n? That's how we're going to represent the formula for sample mean. Now listen, in this one case, you don't do anything different calculation-wise when you calculate the population mean, but we just have different symbols for it. So the symbol for population mean is our mu. And we have the same idea, sum of x. The x values don't change, but now we're just going to use capital N. So just get used to the idea that when we're talking about parameters and when we're talking about statistics, we may be using different letters even though we might be doing exactly the same thing. These do you see you do exactly the same thing? You should call them something different. That's it. Let's go ahead and give this a try, just to make sure we have this idea down. Are there any questions before we get on? Before we get on to this thing. So we have this idea called center. It's like the middle of our data. We haven't talked about any of these yet. We're just really on our mean so far. But the mean is calculated by adding up all the values divided by the number of values you added, whether you're in a sample or a population. So let's take a look at this sample of data. You know, it'd be awesome if someone's watching that video and they hear the cow noise and be like, dude, I guess you got a good cow noise. Get hired off of YouTube to do cow noises. I would love that. It'd be like my part-time job. Just be the moo guy. The Mew guy. Oh, that gives me my nickname. That's so awesome. What's up, Mew? Good to see Mew. Are Mew doing good? So our sample data is this. We have, let's say this is the sample of every month you counted the changes in your car or something like that. Here's what you got. 540, 110, 42 cents, 73, 48, and then another month you happen to have $1.10 at the end. How many data values are in our sample right now? Let's count. Okay, so if we're talking about finding the mean, firstly, am I going to be using x bar or am I going to be using the mu? Which one? Great, because it said sample data, right? That says we're going to be talking about x bar. X bar says you're going to add up all the data and divide by the number of values you added. So if you're going to fill this thing out appropriately, our sample mean, x bar, it's called sample mean as well as x bar, we're going to add up all those numbers. So 5.40 plus all the rest of them. And we're going to divide by the number of values we just added. You all said there's 6 pieces of data, so we're going to add this up first, and we're going to divide by 6, figure out how much that is. Why don't you do that now? You all should have a calculator, right? Has anybody added them up already? How much you get when you add them up? 9.23? Anybody else get 9.23?
Yeah.
Awesome. And then we divide that number by 6 and tell me what you got. 1.54? Okay, I'll take it. How many people were able to get 1.54 on their papers? Awesome. Now, is 1.54 itself anywhere in our data set? No, it's not. It doesn't have to be. The average just says this is the number that most of these things are close to. That's really what it says. It says if you happen to have money in your card, that considering your data for the past like 6 months, you're probably going to have about or close to $1.54. Does that make sense to you? That's the expected value that you should have in your car. It's also another name for the arithmetic mean. It's expected value, what you should have. Do you feel good about calculating the mean? So if I give you some numbers, you can add them all up and divide and get that, right? Let's go on to the next one. It's called the median. Have you heard of the median? Now the median is used a lot in mathematics because it has some special characteristics to it that we're going to talk about. In your real life, you probably hear like median salary or median home value. You ever heard that before? Why don't they use the average? Why don't they use the arithmetic average? Why do they have to use the median price of a home? We'll talk about why in a little bit. But think about that right now. Why don't they add up all the home values and divide by how many home values are added? Because information's there. Why don't they do that? I want you to think on that for a second. Okay, so the median. The median really is the middle. It's the middle value of your data set. That's what we mean by that. The middle value of the data set. I'm not sure, but I think your phone might be ringing. Sorry, Valerie.
I'm sorry.
It's okay, I understand. It happens. Never to me, but it does happen. the middle value of a data set. Let me ask you a question. If I just gave you a list of numbers and asked you to find the middle value, would it work all the time? What's it imply if I say the middle of something, the middle of a list of values? What's it imply about those values? For instance, can I just give you the numbers? Would it be good to find the middle value of this set the way it is right there?
Now you have them in order.
Why do you have to have them in order?
I don't know. That's what you do.
Okay. You're right. Why not? Well, because when we say the middle value, it's implied that it's in order, because if it's out of order, this could actually be way an outlier. Well, we haven't even talked about outliers, but it could be way outside the normal of our data set. It wouldn't be actual middle. So middle does imply, like you said, in order. So the big thing about our median, your data values must be in order from smallest to largest. So that has to happen. That's got to happen. And then literally all we have to do, that's the hard part, that's honestly the hard part, is getting it in order, because that takes the most work, because you have to organize it, it takes time. It's not hard to do, it just takes time. So you have to organize your data in order, that's important, otherwise your middle number is not necessarily the middle of your data set. That would be a problem. 7 is clearly not the middle of that data set. So it's got to be in order, and then we find the middle value. Here's how you do it. So find the middle value. Where there's only two cases. You can either have an odd number of data values or an even number of data values. So you either have like 3, 5, 7, 9 data values, or 2, 4, 6, 8, something even or something odd. If you have an odd number of data values, it's actually a little bit easier, because when you look up here, we have 1, 2, 3, 4, 5, 6, we have 7 data values. There's going to be a middle value. You with me on that? So if you have an odd number of data values, you just take the middle value, that's your median, once it's in order. So if odd number of values, the median is the middle number. That's right up there, I don't have enough room. Well, what happens if we have an even number of data values? There's still got to be a median. And so what we're going to do, let's say we had this like 1, 3, 4, 5, 6, 7, something like that. We clearly have an even number of data values here. We have 6 of them. So when we look for the middle number, it's not anywhere. There is no middle number. So what we do, we take the 2 middle numbers and we average them, an arithmetic average. So we're going to use that mean idea within there. So here, if you average these together, you'd say 4 plus 5, and then divide by 2, how much are you going to get? Exactly 4.5 in this case. That would be our median here. So if you have an even number of values, you're going to average the 2 middle values there. I'll be even more specific. I'll say find the mean. If you have an even number of values, the median is the mean of the 2 middle numbers. So in our case, the median, capital letter M, here it's 4.5. Let's give this a try, shall we? So let's do an example with these numbers. So what I'd like you to do is make sure you can find the median of these numbers. Go for it. What's the first thing that you have to do when finding your median here? Okay, so is our median 11?
No.
Not necessarily. It could be that number, but it has to be in order for you to really know that. So here, yes, you're right. We'll put them in order. What's the first number that we have?
3,
And then
4, 5, 6, 8, 9.
perfect. Is the median easy to find in this case? Yeah, absolutely it is. The median is the middle number. There's 1, 2, 3 on this side, there's 3 on this side, so our median is right there. Median is 6 itself. Now let's do one more case. Let's say that we add another number on here. I'm going to do this for 2 reasons here. So we got the 3, 4, 5, 6, 8, 11, 13, and 412. It's random, I know. Weird. Is the median still 6? What is the median in this case? It's somewhere between these two values, isn't it? These are the two middle numbers because we have an even number of values now. So it's actually right in the middle of those things. We can do that by an average. So what is the average of these two numbers then? So that is our median. So our average is going to be, our median is going to be 6 plus 8 divided by 2, or in other words, we're going to get 7. Keep in mind that you can do this with decimal numbers also. I've given you 2 examples of whole numbers, but if we wanted to find the median of this data set, 1, 2, 3, 4, 5, 6, we could certainly do it, couldn't we? Do you want to try that one?
Yeah.
Let's try that. Why don't you find the median of this data set? Make sure you put them in order first, okay? I'll do that problem right down here. I did forget one. Which one did I forget? Every time. There, is that better? Okay, that's better. Okay, you have them in order, right? Let's find the median. Hopefully you've done this already. The median, since we have an even number of values, you see that, right? We have an even number of values. The median's not apparent to us, but we do have these 2 that are right in the middle. Now, in the other case, it was pretty easy to find the median because you're like, oh, well, what's right in between 4 and 5? Well, that's 4.5. That's pretty easy. What's right in between 6 and 8? Well, that's 7. That's a no-brainer. But here, you are going to have to know how to average those to find the median, right? So we do the same exact thing. We add them together, we divide by 2 in this case. What's the median for this range of data? 0.915? Did anybody else get 0.915?
Yeah.
So we add them together. Divide by 2, and they'll say that we get 0.915. Perfect, that's our median. How many people understand the idea of a median? Okay, good. Now, why in the world would we use a median? I asked you to think on this for a little while, and this should have given you a real good clue as to why we use the median when I added that huge number over here, when I added that one. Or when we look at what this 5.4 does to the mean as compared to the median. I want you to notice this. Okay, look at the board with me real quick. Look what happens to what the 5.4 does to the mean that it doesn't do to the median. Watch. If I change this 5, let's say that for some reason you came across like a pot of gold or whatever, and so that change is now in your car, and for this month, instead of having $5.40, you had like $310.05. Okay, pot of gold, that's awesome. Is this going to change the mean? The mean. So the mean, absolutely. Because you're going to add it right here, and this mean's going to go way, way, way up. Do you see what I'm talking about? Is it going to represent most of your data? I mean, if you ignore that one, what you have here is like, I don't know, I'd say somewhere around 75 cents a day, maybe 65 cents a day, if you ignore that 5.4, if you ignore this one. But as soon as you add this thing in there, some of you are zoning out, pay attention to me. As soon as you add this one in there, it explodes your mean. Now, if I change this 5.4 to the $310.05, does the median change? No, it doesn't. What's that mean for us? Well, that means that this 310, we're going to consider that an outlier. What an outlier is a data value that is way outside the norm for most of the other data. So notice how 310 or 412 is way off from the other numbers. You see that? And the 310 is way off from the other numbers. That's called an outlier. It's not even close to the majority of your data. A mean is very affected by outliers because you're adding up all the data pieces. A median's not, because you're just putting them in order. So this is why they do median household income and median home value rather than mean, because people like Bill Gates throw it way off for everybody. I mean, he makes well, he used to. He used to make billions of dollars, right? Do I make billions of dollars? Not that you know. No, I don't. I make thousands of dollars, but not billions of dollars. So his income, if you did the mean, would make it seem like everyone was getting more than they actually are. Do you see what I'm saying? Because if you add it in there, but divide it across the whole population like we do, they use median because if it's all in order, those outliers to the far, like richest 2%, 1% are excluded, and those at the far left, the lowest income, are excluded, and we get what most people are. That's why they use median. Same thing with home values. They exclude the median excludes the really low ones and the really high ones. They don't really play a factor in there. Did you get the idea here? You get a better picture of what's actually going on. In some cases, if there's lots of outliers, by using the median. So that's our idea. So one little note here, the median is not affected by outliers, the mean is affected by outliers. I know I'm hanging that one out there, but what I mean is affected by outliers. I just don't want to write it. Do you have a good picture about the mean and the median at this point? Feel pretty good about that. Good. There's one more. We really don't use this one in this class. The last one is the mean, the median, and the mode. Yeah, it's the mode. The mode means the most. What happens the most in a data set? That's really it. If a data value occurs more than any other, that's called the mode. That's what it means. Let's say the mode is the most commonly occurring data value. there's really four options. You can have a single mode. You can be what's called bimodal if two values occur with the same frequency. You can have multimodal, which is like three or more that have the same frequency, or you can have no mode. No value occurs more than once. That's really our only options here. So let's take a look at some examples. Let's do that. The first one that we have, the 5.41. Bless you. Does it have to be in order for you to find the mode? That doesn't matter. Just one the number that happens the most. Does this one have a mode?
Yes.
What's the mode here? Okay. The next one. Does this second data set have a mode? It doesn't have a single one, but it has, how many, is it bimodal or does it have three modes?
It's not.
Two or three? A lot of people get confused here. They go, oh, but wait a second. This one's also repeating. Doesn't that count as a mode? And the answer is no, it's not. It's the most repeated value. And if there's two that happen the most amount of times, then you count both. But you don't count everything that repeats as the mode. That doesn't make any sense. So here we'd say, yeah, this is bimodal. In this case, the modes are 27, that occurs 3 times. 55, that occurs 3 times. 88 only occurs 2 times, that doesn't count. How about the last one? Any mode there? You can put no mode or just do that. That's the empty set. There's nothing. There's no mode going on there. Okay, one more thing about just kind of rounding, and I think you did it here. You guys actually did it there. There's something called the rounding rule in statistics. Here's the rounding rule. The rounding rule is it's kind of a rule of thumb. You don't have to stick with it all the time, okay? And if you give me a little bit off on your test or your homework, I'll be like, okay. But here's the rounding rule. The first part is the rule of thumb. The second part, you have to do this. The first part's this. You're always going to round a number to 1 decimal place more than what they gave you. You're going to round a number to 1 decimal place more than what they gave you. For instance, if you're given whole numbers, we're going to round to the 10th. If you're given, like here, 2 decimal places, notice how the answer's in 3 decimal places. Do you see that? You round to 1 more decimal place than the value you're given. That's the whole idea of the rounding rule. The second part is this. We're going to deal with formulas where we're using numbers and then using those numbers in a different formula and using those numbers in a different formula. If you keep rounding every single time, you are going to be off drastically at the end of our problem. So here's the deal. In our class, you can't round until the very last step. Nod your head that you're with me on that. You cannot round until the very last step. So if we're using the mean in a formula, we actually can't use that. We're going to use a much longer value because it's more accurate. Because if you use this and we have to reuse that, your error is multiplied. So the 2 rules for rounding are, you give me 1 more decimal place than the values you're given. That's at the end of your problem, because you never round until the very end of your problem. How many people are with me on this? Okay, good. That's the 2 rounding rules. Now, we can find also the mean of a frequency distribution, like what you guys made up on your homework. We can find the mean of that. Now, it's going to be an approximation because, did you notice on your frequency distributions or frequency distribution, that's hard to say, distributions in general, that when you make up a frequency distribution, you have a class from like, we had 18 to 21-year-olds, right? And we put like 25 people in that class. Was everyone in there the same age? No, we had like 18-year-olds and 19-year-olds and 20-year-olds and I think 21-year-olds or something. We had all those ages in there, and there was different people in that class. Maybe all 25 of you were ranged between 18 and 22 or 21. Excuse me. But when we put it in a frequency distribution, we lose that information. We don't know how many exactly 21-year-olds there are. So what I'm about to show you is an approximation, but we can find a very close average for a frequency distribution. And here's how we do it. So we're going to start off with a frequency distribution over here. Here's one that I already had made up, so we use this. Bless you. That was a good one. Oh, you really let that one out. Awesome. You know, I just get a kick out of people's sneezes because I'm a teacher. I hear lots of different sneezes. And you all have very interesting sneezes. Do you know that? I'm sure mine are interesting too, but everyone's got, oh, never mind. Okay, make up a table like this one. Yeah, that'll be good. And this is another age distribution. And I think this was from my my first class teaching statistics here at the college. I taught a summer school class. And here was my distribution that we made up. Oops. I already screwed something up. What did I screw up? Yeah, otherwise 30 would be counted in two places. That wouldn't be good. Hey, just to kind of refresh your memory, I like to do this often also to kind of spiral some information. How many classes do we have here? So our classes are each individual group. What are our lower class limits? What's the first lower class limit? What's the next lower class limit? What's the upper class limit of the second class? Good, okay. What is our class width? Good, it's 10. It's not 9, right? It's 10. It's between the two lower class limits. You got that? So the class width is 10 here. Good, all right. What's our first class midpoint? Use your calculator if you have to. Do it in your head if you can. 25.5. You got it. Anyone else get 25.5? Is that what you're thinking? How do you find the class midpoints? Add these two?
No.
Add these two. And then divide by 2. Hey, we've already been doing that idea. That's the average again, okay? So yeah, the first class midpoint is 25.5. The next one is 35.5 because you can just add the class width to find sequential class midpoints. You with me still? Here's a tough one. What's the very first class boundary? 20.5 is the first class boundary. That's right. What's the next class boundary?
35.
Perfect. Very good. Okay, so we have the information back again. Here's the frequencies. Now here's how we do the average or the mean of a frequency distribution. What we do is, since all of these 28 people might have been different ages in there, and some were the same age, but you could have every age between 21 and 30, agreed? We don't really know what's what. What we do is we say, okay, since I don't know who's who and what's what in this, I'm going to pick a single value that I can use to represent all 28 of these people. Are you with me on this? The single value is going to be just the middle of our class. or in other words, a class midpoint that I just had you create. So right over here in this column, what we're going to do is put our X, but our X is going to stand for our class midpoint. Midpoint. And you already told me the class midpoints. It was 25.5, 35.5, 45.5, and so on. I know it seems a little weird, and this is why it's the approximation, but here's what we're doing. We don't know the age of every single person here, so what we do is we pick the middle of our class, and we're going to pretend right now that every person, all 28 people, were 25.5 years old. Okay? And every person here, all 30 of these people were 35.5 years old. Do you get the idea? That's the only way we can calculate it. And so what we're going to do, in order to figure out our average, we're going to multiply f times x. That gives us all 28 at the age of 25.5. So you're multiplying the age of each person times all those people. So multiply this out. Let's do this quickly here. Can you give me... Some people start working from the bottom because I want those numbers quickly. So you guys start working from the bottom. You guys start working from the top. Top people, does anyone have 28 times 25.5?
714.
714, okay, very good. How about the next one? Quickly but correctly.
1065.
Thank you. Next one.
546.
These ones? This one?
111.
Yep.
131. 151.
Perfect. Hopefully that math's right. If you double check, did someone double check those? Great. So we have all the frequencies times all of the values that we're considering each of these people to be. What this does, this gives us, if we added up all the added ages. See, think about it this way. This right here is all the added ages of 25.5. We added it 28 times. That's the repeated addition multiplication. Here, this is 35.5, all 30 times. If we add all this up, and divide by the total number of people, we're going to get our average. So add this up for me, please.
2,700.
Say that louder for me.
2,700.
And 18? And add this one up for me, because this is our n. 76? Perfect. In order to find our average, what we're going to do is take the sum of f times x, which we just calculated that right here, divided by our n. So in our case, we have 2718 divided by 76. Give me that. How much?
35.76.
Perfect. Seem about right? Look like the average is right around 35 if I consider all this stuff? It's out there. That's how we find a weighted, or sorry, average of frequency distribution. How many people feel okay with finding this thing? Okay, good deal. That's going to end for today. We're not quite done. We have to do weighted averages, but what I'm going to do, all right, so like I was saying, today we're going to talk first about how to find a weighted mean, or the mean of a weighted distribution. This is like I said, like in your class, our grades are weighted. In fact, when we look at our grades for this class, do you remember what your weighted grades were? How much homework was worth? So let's say homework. How much is homework worth for this class?
15%.
15%, that's right. So it's not really a point system, it's a percentage system. So 15%. So homework's worth 15%. And how many tests do we have in here?
3.
So we'll have test 1, test 2, test 3. How much is each of those tests worth? 20%. Is it 20? And there's one more thing, we have a final. final's worth, I think that leaves 25%. So let's say you're taking this class, which you are, and you have this weighted scenario for your grades. And we want to figure out what your grade's going to be at the very end. Well, that averages everything together. So here's how we find the mean of a weighted distribution. What we do, so here's our weights. We'll call those W. Let's see how many points you have. So we'll see how many points you have out of 100. Okay, so you did your homework. How many points do you want to have out of 100 points? Well, yeah, but what if you miss some? How much do you think you're really... Let's say that you do most of the homework, so you have like, let's say you do 70 points out of 100. That's what you get. It's all said and done, 70 points. And then your first test, are you going to do good in your first test?
Yeah.
Get like a 90% of your first test. 90 out of 100. So 90, these are all out of 100. So one way that we could make this out of 100 is take your score, like the number of points you got, divide that by the total number of points, and that would give you something out of 100. Are you with me on that? We would change it to a decimal version of that. So this is the same idea. So you get 90 out of 100 in your first test. Second test kind of hard. Just gotta warn you. So second test you got like a 68. Ooh, you have to bounce back from that one. Third test you did really well though. For the third test, you got an 85. And the final, what are you going to get on your final? It's cumulative. Be optimistic. 95. We'll get 90. 95 is very optimistic. Okay, that's good. So you got 70 points out of 100 for your homework. You got 90 points out of 100 for your test 1, 68 out of 100 for test 2, 85 out of 100, and 95 out of 100. Now keep in mind, if these aren't all out of 100 points, there's one very easy way that we can do this. Let's say that you actually had, for your homework, because we're not just going to have 100 points of homework, we'll probably have more like 220 points or whatever. Let's say that you got 185 points out of a possible 220. Okay? This is one way you can convert that to points out of 100. You do this and then multiply it by 100. Not 1,000. You get 1,000,000 points. Congratulations. So you do the 185 over 220. How much is 185 over 220? It should be a decimal. Come on, you all have calculators. So 0.8, about 0.84, is that what it is?
Yeah.
So this is 0.84, and then to change it to one of these numbers, you multiply it by 100, and that's just going to be moved the decimal place twice, you get 84. That's how many points you would get there out of 100. Does that make sense to you? So you can convert any point scale into this scale, and that's what you would do for this class. So now, how in the world do we figure out what the mean of this whole thing is? What your grade is going to be for this? And it's very, very similar to the idea of a frequency distribution. Here's what we do. The first thing we have to do is calculate what percentage of this is weighted. So we're going to go ahead and take whatever our points are. Here our points are going to be our X variable. That's the data that you've kind of collected, right? You have 70 points out of 100. That stands for your data. If your homework value is worth 15% of your total grade, what we're going to do is we're going to find out X times W for each region. Very much. Does this look familiar to the frequency distribution mean that we did last time? Really, really similar, only instead of a midpoint, now we're using the point value for your homework and for your tests, things like that. So can you tell me what is 15% of 70? Remember to translate 15% to a decimal, we're going to make that 0.15. You do that decimal place twice. What is 15% of 70? Say that again?
10.5.
10.5, okay. How about 20% of 90?
18.
Even?
Mm-hmm.
Oh yeah, I guess it would be, wouldn't it? I'll put 18.0 to keep it honest up there. 20% of 68, how much is that?
13.6.
Perfect. 20% of 85.
17.
Right. And 25% of 95.
23.75.
Ladies and gentlemen, are you okay getting these numbers? Do you see how these are being calculated? We're taking these x's, your point value, times each corresponding weighted value as a decimal. So here we're taking 0.25 times 95, 0.2 times 85, 0.2 times 68, and likewise 0.15 times 70, we're getting these values. What did we do in a frequency distribution after we got all these individual values? What did we do next? Say that again?
Add the total.
Yeah, that's right. We're going to add these all up. What this is going to give us, what's the symbol that we use for addition again in this class? It says add them all up. Yeah, that one right there, our sigma. We're going to add up the XWs. Add up the XWs for me. Hey, have you added the all the XWs, X times W's? Did you get that yet?
Mm-hmm.
Add them all up, how much do you have?
82.85.
Perfect. Here's the last little bit. In order to find the mean, this is a sample mean. What we're going to do is we're going to take the sum of your X times W's divided by the sum of the W's, the weights. So what you need to do is figure out how much this all adds up to. Now this one's going to be pretty easy. How much does this all add up to?
100.
Okay, so if we do this, divide by 100, we're going to have 82.85 divided by 100. Of course, dividing by 100 in this case is very easy. It's just moving our decimal place 2 spots to the left. We get a 0.8285. And that's your grade out of 1. So that's the proportion of your grade right there. So as a percentage, you could change it to a percentage, right? Change the percentage by pretty much undoing this step, changing it back to 82.85. That's your grade in this class. You would have about an 83%. So you'd have a middle of the road beat. Does this make sense to you? Now this seems a little weird. Why in the world would you divide by 100? Well, this doesn't have to be out of 100%. I mean, you could figure out what your grade is at any given time. Have we honestly taken all these, have we done all this stuff?
No.
No? So if you didn't do this much, could we figure out what your grade is after your first, after the homework that you've done and the first 2 tests? Could you do that? Okay, if we wanted to do that, we would just erase this stuff. Can someone add that for me as I'm doing? I'm going to add this up. This will be 55. So we'll be dividing by 55 here.
42 forward.
So if we do this a little differently, if we just say, I want to figure out what my grade is after my first 2 tests and the homework that I've done so far, you're going to take these point values, multiply them by their respective weights, we'll figure out what that is, we'll add them together, 42.1, then we divide not by 100 because you haven't done everything yet, right? You've only done, well, the weighted version is only 55%, so we'll take the 42.1, divide that by 55, how much is that?
.7654.
Hey, what does .7654 mean to you? Yeah, it does. That means a C. Because this is around 76, 77%, 76.5%. So using this, you can calculate your grade for this class at any time. You can just figure out how many points you have out of how many we've done total. figure out this version of it, which I showed you how to do right at the beginning, multiply by the appropriate weight, add it together, and divide by the weight that you've accomplished so far in this class. If you've done the first 2 tests, you've accomplished 55% of it. How many people understood how to do that? Real similar to a frequency distribution, followed pretty much the same pattern, and we have to think that. Okay, the last thing we gotta do in this section, I have to talk about something called skewness. You ever heard of skewness before? You have now. Skewed. We talked about normal. Do you remember what normal meant? Normal, like on a graph, meant that if you look at it horizontally, the graph has a tail on the left and a tail on the right, but it's pretty darn symmetrical. It goes up to some value that most items are around, so most of our data is in this range. We have a few outlying pieces of data, but it's a pretty bell-shaped curve. Actually, that's a really awful bell shape. I'm going to try to do better. I'm not very good at this. That's better. That's a normal curve. Or pretty close to normal. We also have 2 other options, well not options, but 2 other scenarios that we could have. If it's not normal, it's most likely going to be skewed one way. A skew is like a lean, like where it's where we have more outliers. So for instance, do you see how this tail is kind of starts out a little bit steep? Let's make it steeper. Like that. Starts out steep, and then we have this long tail on the right-hand side. That tail on the right-hand side, that says to me right here that while most of the data is here, I have a few really large numbers that are skewing the data. Those are called outliers. You remember talking about outliers last time? Do you remember that? Outliers skew your data. Outliers say, okay, most of it's normal, but then I have some pieces of data way out here that's making my tail push to the right. This is called tail right or skew right. Now, I know you want to say left because most of the data is left, but we look where the tail's at. It's skew right. Or skewed to the right. What that means is you have outliers on the right side of your data, the larger side. We also have the other situation. We could have tail left or skew left. This means that most of the data is normal in one area, but we have some outliers on the left-hand side of our data, the smaller side. So from this, can you take a look at some graphs and figure out whether it's normal or skewed left or skewed right? You might even be able to do this with just data, like a frequency distribution, and look at it and see whether it's skewed left or skewed right. The one that we did with age. Remember the one we did with age where we made the histogram up? That was definitely skewed right because we had a large number here and it's skewed off this way. That was skewed to the right. Oh, by the way, let's see. Oh, I hope this works. Would you like to see how to do mean, median, and mode on your calculators if you have a nice calculator like that one? Would you like to see that? How many people have a graphing calculator in here? Okay, it's worth me doing that. Well, it's like 2 of you. I'm not going to do it. Oh, no, it worked. Now the problem, ironically, is I forgot my calculator. So can I borrow someone's calculator?
I'm prepared.
Yeah. It's just those. Well, thank you. You ever tried to move something like this? It feels like you're going the wrong way. It's so strange. Does that trip you out? It's so fast. Let's turn some lights on, see if maybe that'll help a little bit. Give it a second. There you go. Can you see this? You see the little blinky thing? Follow me along with your calculators. All the TIs will be very much the same, unless you have TI 89, that's a little bit different. I'll show you that later. What I want you to do is go to where it says stat, because hey, what class are we in? Awesome. Go to stat. Right now you'll see that the number 1 is highlighted, that's the edit button. What this does, if you click enter right now, it's going to bring you to your list of lists. See all the lists? You have list 1, list 2, list 3 up at the top. You can enter data from here. So let's pick some numbers. I'll pick the numbers, plug these in with me. 9. You can press enter or down. You see where I'm pointing? Either enter or down. 9, 5, 2, 6, 7, 9, 9, 1, 5. Let's pick those numbers. Right here, you'll be able to scroll back through your list, pick those numbers out. It says you have 10 items in your list right now. Have you all been able to punch those numbers into your calculator as you were going? Is everybody with me on those? Okay. This is kind of cool. What I want you to do now, press the stat button again. It'll take you back to your original screen that we started with statistics. Now, your numbers are still in that list, okay? They're not lost anywhere. They'll be there until you go back and erase them. It's stored in your memory. I want you to go over to calc. Calc means calculate, not calculus, unfortunately, because that would be awesome. It means calculate. So we're going to go over to calculate, and you're going to do what's called one variable statistics. It's the first thing highlighted. Press enter. It'll already have it might not look exactly like that. It might look a little bit different. It might not have this information. It might just say one variable stats and then have a room for you to type something in. Do you see that? Okay, if that's the case, okay, so your calculator. If this, why is your calculator blurry?
It's hard.
There you go. Okay. So if it says something like that on your screen, what you're going to do, you probably can press enter and be just fine. I think that'll work. But if you want to make sure, do you see this? See down here where it says the yellow L1, or you'll have something similar on your screen. Do you see that? You're going to press second. That's how you get to that part of it. Second gives you, in this case, the gold letters. Press the number 2. Oh, I pressed the wrong one, sorry. Press the number 1 for L1. That'll give you your first list, and your screen should look like that. Are you with me on this, folks, so far? Nudge your head if you are. Okay. If you have a calculator, you're not right here. Oh. So everyone's over. Now, after that, since you have one variable statistics, L1, all you gotta do is press enter. On this calculator, all you have to do is press enter, enter again, and it does the same thing. Okay, it says up at the top one variable statistics. Now, can you see all the information this gives you? This, without doing a whole bunch of work, is going to give you, what's that? What's this mean? That means the mean. Hey, that's what type of mean? Sample mean. Great. It doesn't have the population mean because those numbers are the same. You have to know what's population, what's not. This is the sum of everything. If you add it all up, you get 53. That's kind of cool. We'll actually be using that later. If you add up all the data items squared, we'll be using that later, as a matter of fact. They'll give that to you. These two things right here we'll talk about in the later part of today. We will get there. It tells you the number of items you have in your list. Apparently I guess I was off by 1. We had 9. I got that wrong. If you scroll down, it will give you your minimum, what's called a quartile. We'll talk about that next time. The median, which you had to put data in order to get that, right? That's annoying. I mean, you do it right from here. median, Q3, and the maximum, all within just like 4 pushes of the button. You put all your data in, for any data, decimals, whole numbers, doesn't really matter, negatives, positives, whatever. Put it all in your list, you press stat, calc, one variable statistics, enter, it does it all for you. Is that not cool? It's awesome. If you forget how to do this, where can you find this information again? You're so smart. Okay. So that was neato. We can do that. That's the first time that's actually worked for me, like without any problems, ever. Fantastic. So do you feel good about finding mean, median, mode, making up frequency distributions, calculating the mean of those frequency distributions, and calculating the mean of a weighted distribution? How many people feel okay with that? Good. That's all the concepts we've really covered so far. Now, we're going to get on to the second characteristic of our data. And that means, Karina, we're going to get set up onto variation.